Good morning.
Good morning.
Good morning.
Another lecture today. Please be prepared. And another thing what I would like to say, I am definitely getting emails from my students. The only thing I told you about that, unfortunately, maybe some people forgot about this. I'm talking about providing personal extensions for certain assignments on my math lab because you accidentally overlooked or for any other reason. Unfortunately, I cannot grant this type of extensions. Try to be on time. I all the time tell you to several times a day. When I say several times, I did not mean 100 times or 50 times, no, but at least 2-3 times. Please check my math lab site to see if any new assignment is there. Another email which I received, it was from the student. She was a little bit confused, and I really like to help her to be released from that confusion. I definitely will explain what should be let's say associated with the sign for cosine, sine, or any other value of trigonometric function in any quadrant. And the only one thing I was a little bit confused. Is it okay if I actually release the name of that person who asked me about some negative sign in the email?
Yeah, me.
Yeah, but I wanted to ask your permission first. So it was Bhaktima, and you sent me that at early morning today, right?
Yeah.
Okay, so I definitely will try to answer your question. So, but I need to clarify the nature of that question because it was a little bit, you know what, confusing for me. Don't be surprised about new surrounding which you see on the screen. I am already in my house in San Francisco, as I already announced that to you, but I'm just trying to find more comfortable for me space to do that because you know what, where you can try one spot in your house, another spot, so please be surrounded. I did not travel to any other place. I'm here in California. So I am going to definitely check emails, but first I would like to answer Bhaktima's question. So 1 second, please. I'm grabbing my telephone because the question came in the form of email. Just 1 second, and I will be with you. Just 1 second. Bhaktima is right here. She sent me an image. So Bhaktima, can I please ask you to clarify what you are asking me about? Are you asking me about a question which is colored in the green color?
Yeah.
Why, let's say, cosine of 3 pi over 4 is negative?
Yeah, because your example is not negative. Okay.
No, you say your question is why, let's say, cosine of 3 pi over 4 is a negative square root of 2 over 2. Is it clear?
Yeah.
That's it. Now everything is clear. And I'm going to prove it right now. And I hope it will be quite interesting for other people. Because, again, this kind of questions, you know what, gives us an opportunity to review important what I'm writing. Cosine of 3 pi over 4. Is it what you are asking about?
Yes.
Excellent. Let's repeat the signs of cosine in our unit trigonometric circle. In our circle, pi over 4 is equivalent of 45 degrees, right?
Yes.
This circle is divided by x-axis and y-axis, which are perpendicular axes, into 4 quadrants.
Yeah.
Quadrant number 1, quadrant number 2, quadrant number 3, quadrant number 4. What is specific about all these 4 quadrants? Can we say that in quadrant number 4 point, x coordinate and y coordinate are both positive?
Yes.
I'm talking about first quadrant. I would like to ask all other students also to participate in this discussion because we are just reviewing. In the second quadrant, x coordinate is negative, but y coordinate is positive. So they have different sign. X is negative, y is positive, correct?
Yes.
Let's move to the next quadrant, number 3. What is special about number 3 quadrant? Is it true that in quadrant number 3, both coordinates and x and y are negative?
Yeah.
Yeah.
And finally, in the fourth quadrant, which coordinate is positive? X.
X.
Which coordinate is negative?
Y.
Y. So, conclusion. In 2 quadrants, number 1 and number 3, x and y carry matching signs. In first, it is plus, plus. In the third quadrant, minus, minus. I'm talking about signs for x and y.
Yeah.
In second quadrant and in the fourth quadrant, they have opposite signs. One is positive, one is negative, right?
Mm-hmm.
Let's find in degrees equivalent of 3 pi over 4. What is the meaning of 3 pi over 4? Is it 3 times pi over 4?
Yes.
Is it 3 times 45 degrees?
Yep.
If you multiply 3 by 45, what do you get? Is it 135?
Yeah.
135 degrees is located in what quadrant?
Quadrant 2.
Quadrant number 2. Our cosine, by its definition, is affiliated with x coordinate or y coordinate?
X.
X coordinate. In the second top, look what we did. We found the location for 3 pi over 4. It is the second quadrant. We are thinking about coordinates for any point in the second quadrant. And we know already x is negative in the second quadrant as a coordinate, y is positive. So cosine, again, we just said, according to its definition, is affiliated with the x coordinate. Did you say so?
Yeah.
Which is correct. So x coordinate in the second quadrant is negative. Does it mean that cosine also should be negative?
Yes.
That's it.
Okay. I forgot. Thank you.
Are you satisfied now?
Yeah. So,
But I will show this to you from other point of view. This is one explanation. Again, cosine of 3 pi over 4 is negative. Why? Because this angle belongs to the second quadrant. And because cosine is affiliated with x coordinate and x coordinate all the time in the second quadrant is negative, cosine should be negative for any angle from the second quadrant. And because 3 pi over 4 is in the second quadrant, its cosine will be negative. Now, second, now I'm not going to verbally explain. I will show this on the paper. So 3 pi, can I write it down like 4 pi minus 1 pi?
yes.
And I'm going to simplify cosine 4 pi over 4, it will be pi, and it will be pi minus pi over 4.
Okay. Yeah.
So what I'm going to do, I'm going to use that rule. So what kind? We know already that cosine of 3 pi over 4 in the second quadrant is negative, and 3 pi over 4 was in the second quadrant. So I put already equal sign and minus. After that, look inside of this parenthesis. What do you see? Do you see a you have a quadrantal angle here. Is it vertical or horizontal? Pi is a quadrantal angle. Is it horizontal quadrantal or vertical?
Horizontal.
If
Horizontal.
horizontal, do we keep the same function or switch to another one?
Keep.
Keep. So we will be keeping cosine. And the reference angle is pi over 4. So we basically proved that cosine of 3 pi over 4 should be equal to negative cosine of pi over 4. And just plug the value for cosine of pi over 4 at the square root of 2 over 2. So together you have the answer. The answer is negative square root of 2 over 2. This is another proof.
Okay.
But I will not be satisfied with just 2 proofs. Now I am going to prove this in the third method. So first method was verbal, we described everything. Second, I proved that using that rule. And now the third method. So this was the second method. This now is the third. Again, I'm writing down 3 pi cosine of 3 pi over 4. First steps are very similar to the second method. And I'm just going to show it to you right now. Don't worry, guys. You can even write it down. So this is the third method. So far, first steps are very similar. There are 2 steps which I took, very similar to what we did in number 2. But now I will be acting differently. Please look at cosine parenthesis pi minus pi over 4. Is it fitting the formula cosine of alpha minus beta?
Yeah.
Yep.
Cosine of difference of 2 angles. Now I will continue. Cosine of alpha minus beta, in our case, our alpha is pi and our beta is pi over 4. I even wrote below that it is actually cosine of alpha minus beta. According to this formula, it will be cosine of alpha, for our case, it will be cosine of pi, times cosine of beta, which is pi over 4. When we have cosine of the difference in the formula in expanded form, I should use sum, which will be plus sign. Plus what? Sine of alpha, which is pi, times sine of beta, which is pi over 4. I use that formula for cosine of alpha minus beta. Let me expand that formula here also. Cosine alpha, cosine beta, plus sine alpha times sine beta. Please write it down, and I will continue in a second. Now, do you let me continue, guys?
Yeah.
Yep.
And I'm going to plug values. So, cosine of pi, what is the value? -1. Cosine of pi over 4, what is the value? Square root of 2 over 2.
Yeah.
Plus sine of pi, 0. Sine of pi over 4, square root of 2 over 2. Instead of each of these components, I wrote down their numerical values. What do you see here? In one product, you have -1 times square root of 2 over 2. So it will be negative square root of 2 over 2. In the second product, you have 0 times that number, which will be 0. So this is what you have. If you are adding negative square root of 2 over 2 and 0, is it negative square root of 2 over 2?
Yes.
Yep.
And this is the third method in which I also prove that it will be negative square root of 2 over 2. Dear Bhaktima, are you satisfied with 3 different methods?
Yeah, thank you.
You're welcome. And trust me, the best thing when you are so confused is to visit my office hours, because I provide office hours at the same time as we had during regular classes. It is on Monday, Wednesday, and Friday. And I'm doing this using Zoom, so we can communicate using that Zoom as a program. And I would be able to explain and release you from your confusion. Is it clear?
Yes, thank you.
You're welcome. Do we have more questions?
Yeah, I do.
Go ahead.
So your office hours, is there like a queue for it? So say you're already in a meeting with someone, how does that work when you're waiting?
Trust me, I will handle it.
Okay.
Because using Zoom at the same time, I can have about 300 people at the same time simultaneously on the same screen like I have. Did I answer
Okay.
your question?
Yeah.
Okay. With your permission, can I please start now talking about today's material?
Okay.
Okay. What do you have here in the textbook? This is another section which is completely based on previous section 3.5, but it is having definitely a different name. This is section 3.6. Can you please write down the topic? The topic for this section is double angle and half angle formulas. It is on page 230 in your textbook, and it is again section 3.6. Section 3.6. You probably already, if you visited my math lab, you probably could see that section should be available for you. And these are 2 different groups of formulas. I will try to use the same numerical order for these formulas because I don't want to confuse you. And I hope that you already wrote down that topic, double angle and half angle formulas. And with your permission, can I start explaining?
Yes, please.
Yes.
Yes.
So, formula number 1 in your textbook is formula for the sine of double angle. In the textbook, it comes like sine parenthesis 2 theta, but parentheses here are not honestly required. It is not a mistake to have sine parenthesis 2 theta, but because parentheses here are not required, it is something extra, I'm going to drop it. This will be the only difference between what you see in the textbook and what you will see during my lecture. I do not like extra elements if they are not required. So this is the formula. Sine of double angle equals to sine theta cosine theta. And you know what? I'm going to prove right now this formula. How can I prove that formula? I'm starting this proof. Let's say I treat this as one of identities and I like to prove this identity. I will start here with the left side. I'm writing sine of 2 theta equals sine parenthesis. Can I write theta plus theta?
Yeah.
Theta plus, and parentheses here are mandatory. And Bhaktima, please, in your email, you need to surround cosine of, I think, pi over 3, pi over 4. You need to have them in parentheses also, because without parentheses, it will carry different meaning. Okay? Please be careful with parentheses.
Okay.
Does it look to you as when it is sine of theta plus theta? And definitely 2 theta is 1 theta plus another theta. Can I treat this as, let's say, sine of the sum of 2 angles, where alpha is theta and beta is also theta? Can I?
Yes.
Right? So look on the top, even in small size, I wrote alpha plus beta. And I'm going to apply that formula. According to the formula, sine of parenthesis alpha plus beta, it will be sine of alpha, which is sine theta, times cosine of beta, which is cosine theta. For the sine of the sum, we have plus on the other side of the formula, which will be sine of alpha times cosine of beta, but don't forget alpha and beta both are thetas, plus cosine of alpha, which is again cosine theta, times sine of beta. And look what I'm getting. I'm getting sine of theta times cosine theta plus cosine theta times sine of theta. Do you see anything special in these two products? Are they practically same thing?
Yes.
Yes.
Why? Because A times B or B times A in the switched form, it's the same thing. So if you are adding same with same, let's say X with X, is it 2X?
Yep.
Yes.
If you are adding the same products, sine theta times cosine theta, you are adding, there are 2 of them. So answer will be 2 sine theta, cosine theta. Is it what we were planning to prove?
Yes.
Can you see how easily we prove that formula? We're done. Questions?
No questions.
Mhm. The last call for questions. Guys, do you have questions?
No.
No.
Okay. Can I please ask you to write down now cosine of 2 theta equals cosine square theta minus sine square theta. And this is actually formula number 2. Formula number 2. Sine square cosine square theta minus sine square, I probably removed very quickly. Cosine square theta minus sine square theta. Can I please ask you to try to prove it using the same approach which I used proving formula number 1? I really recommend you again to start with the left side, which is cosine of 2 theta, and treat 2 theta in the same way like cosine parenthesis theta plus theta and expand. While you do that, I will check today's attendance, and after that, I will be with you. By the way, on the coming Thursday, I will offer you short quiz, and I will explain today how we will take it. So today is May the 5th. So Bryce,
Here.
Gracia,
Here.
Alexia,
Here.
Hannah,
Here.
Demeter.
Here.
I saw your name, Demeter. Okay. So Jesus,
Here.
Ariana,
Here.
Axel, Axel. Okay. Desiree,
Here.
Lila, Lila, Bhaktima is here. Jessica,
Here.
Ivona, Devin,
Here.
Valeria.
Here.
Unfortunately, the last time many people were not during our lecture in presence. You know what, the best thing is to attend these lectures because it is a live communication, and during that communication you ask for help. I can explain, releasing you from your confusion, answering your questions. You know what, this is really important. Definitely to for your benefits, I upload videos on YouTube and you can watch them later, but it will be like an additional benefit. But the best thing is definitely to attend our sessions. Now, I'm going to catch, because you probably should start earlier, and I'm going to show right now what I'm writing at this moment on the paper. And you can check. Did you write what I have on the paper already?
Yes.
Can you see we have cosine theta by itself multiplied in the first product?
Yes.
If you multiply same by same, is it square of that item?
Yes.
So we are getting cosine squared theta. In the same way, can we look at the sine times theta times sine on theta twice by each other?
Mm-hmm.
Is it sine squared?
Yes.
Is it what we had to prove?
Yep.
Can you see? So basically, if you accidentally forgot formula number 1 or formula number 2, at least you need to remember formulas for the sine of the sum of two angles, for cosine of the sum of two angles, and you can quickly prove it to yourself. And finally, after that, you can grab this formula and apply this in your simplification. But look what you have in your textbook. You have only one formula for sine of double angle, but you have 3 formulas, 3 for cosine of double angle. I, right now on this paper, already have formula 1 and 2. And I'm going right now to show 2 other formulas for cosine of double angle, which are cousins of formula number 2. Yes, for some occasions, it is more beneficial to use, let's say, for cosine of double angle, formula number 2. In some cases, it is more beneficial to use formula number 3. In other occasions, it is more beneficial to use formula number 4. The conclusion, we need to know all of them. Okay, I'm starting with formula number 3. I will copy how it looks, and after that, I will prove it very easily. This, what it states. Cosine of double angle equals 1 minus 2 sine squared theta. Can I start my proof?
Yeah.
Yes.
Okay. Cosine of 2 theta equals 1 minus 2 sine squared theta. If I have this 1, I need to prove it. I have this 1 Is it actually sine squared of theta plus cosine squared of theta? Yes?
Yes.
Guys,
Yes.
I'm going to write it on the side. Sine squared theta plus cosine squared theta equals to 1. Our old formula. I wrote it on the side, you can see. And look at what we need to prove in formula number 3. Cosine squared should disappear. This formula only carries sine squared. This why in that formula, which I just wrote on the side, sine squared theta plus cosine squared theta, can I write that cosine squared theta equals 1 minus sine squared theta?
Mm-hmm.
Yes.
Oh my God, we use this so many times when we worked with problems, right? So I really apologize. I started writing this the formula here on the side. This is why I crossed everything out. So, which means, according to the formula which we proved in number 2 formula, we have cosine of 2 theta equals cosine squared theta minus sine squared theta, right? I just repeated what we had in formula number 2. Can
Mhm.
I, with your permission, replace that cosine squared theta, which we had at the beginning here, by 1 minus sine squared theta, which we had here on the side?
Yep.
Yes.
So I'm replacing that cosine squared by, and I will even put this in parentheses, sine 1 minus sine squared theta, followed by negative sine squared theta. Correct?
Uh-huh.
Now, do we have here like terms?
Yes.
Are,
Yes.
are these terms negative sine square and another negative sine square?
Yes.
If you have minus a followed by another minus a, is it negative 2a?
Yeah.
Is it same thing here? Only instead of a, we will be using sine squared theta.
Yep.
And what do you get?
1 minus 2 sine squared theta.
Exactly, I wrote it down. And did we prove it?
Yes.
Yes, we did. So which means this book was not kidding. Yeah, we already are equipped by the second formula for cosine of 2 theta, but it is not the end, because now we are going to prove formula number 4. What do we have in formula number 4? We have the last formula for cosine of 2 theta. What do you see in this formula? Sine squared disappeared. What we have here, we are dealing here only with cosine squared. So it will be 2 cosine squared theta minus 1. This time, this is what we have. Cosine of 2 theta equals to 2 cosine squared theta minus 1. And again, I can treat this as an identity. And again, I will go to the side. I even boxed this. I'm going to write something, and you will tell me if it is legal or not. Look at the third line in the box, which we have here on the side. Is it true that from the top line formula, sine squared theta equals 1 minus cosine squared?
Yep.
Yes.
Excellent. So what I'm going to do, in the formula number 2, which is the main formula which we proved today, cosine of 2 theta equals to cosine squared theta minus sine squared theta. But now what I'm going to do, instead of that sine squared, I will write 1 minus cosine squared theta. Can I?
Yes.
Yeah.
So let's do that. So it will be cosine squared theta minus parentheses here are mandatory. 1 minus cosine squared theta. Agree?
Yes.
And now I like to drop these parentheses. Don't forget you have minus in front of parentheses, which means there is hiding -1 in front of parentheses, which we have to distribute over these parentheses. So we will get cosine squared after equal sign -1 minus negative is positive sign. So, and this what we are getting, dropping these parentheses. Cosine squared -1 plus cosine squared theta. Do we have like terms?
Yes.
Are they identical?
Yep. Cosine squared theta.
Are they both cosine squared theta?
Yeah.
If we add them, what do we get?
2 cosine squared theta.
And followed by what?
-1.
Absolutely correct. So did we prove it? Is it the end of the proof?
Yeah.
Yes.
We are done. You can see I not only listed that formulas, actually I proved all these formulas. So this how we prove these formulas, and they are quite easy formulas if you know formulas for the sum and the difference of cosine and sine. So this section has not only formulas for double angles, but because I showed you right now formulas for double angles, what do I like to do? And again, I will be doing that if I get confirmation from you. I would like to solve right now some problems from exercise page to show how these double angle formulas work. But I would like to prove tangent of double angle first, and after that I will be solving problems for sine, cosine, and tangent of double angles. Is it okay with you?
Yes.
Yep.
Thank you, you are very kind. So I need to grab another piece of paper. I don't have here space anymore. Can I do that with your permission?
Yep.
Thank you. On page number 231, right on the bottom, you have formula number 5. Formula number 5. And this formula is about tangent of double angle. So this formula can be proved in many different ways. But I would like to connect that proof with the formula of tangent of alpha plus beta, tangent of the sum, which means I will be using the same pattern of proof as I used proving sine of 2 theta, cosine of 2 theta. I'm talking about formulas number 1 and 2. But first, I like to write down how this looks, because in other words, I'm going to write formula number 5. This what you had in your textbook. Only you had tangent parenthesis to theta, but again, I already explained that I don't want to use extra elements which are not required. Please write it down, and we are going to prove it right now. Definitely, right now, you need to change something about 2 theta. Again, can we treat that 2 theta like theta plus theta?
Yes.
This why, on the side, I'm going to write the formula to remind you, which is tangent of parenthesis alpha plus beta, which is on the top of the fraction, tangent of alpha plus tangent of beta, 1 minus tangent alpha times tangent beta. This is the formula which we covered and which we worked with in the previous section. I hope it looks familiar to you because we covered already that formula. According to this formula, this tangent will be equal to the fraction if I treat this tangent of 2 theta like tangent of theta plus theta. And I will show to you right now, just let me write it down and I will demonstrate what I am getting on my paper. Only in that tangent of parenthesis theta plus theta, please treat and alpha and beta from the formula for the tangent of alpha plus beta. Like each one, alpha and beta, they both equal to that theta. And apply it. And this is what you will get. Tangent of 2 theta equals tangent theta plus theta. And because of the tangent of the sum of 2 angles formula, it will be tangent theta plus another tangent theta. And downstairs you have 1 minus tangent theta times tangent theta. So far, so good?
Yeah.
Yep.
And now let's simplify. Let's start with the top. Tangent theta plus tangent theta. Is it 2 tangent theta?
Yep.
Yes.
Let's move to the bottom, to the denominator. I copied 1. Now, tangent theta times tangent theta. Is it tangent square theta?
Yes.
Yep.
Is it what we were trying to prove? Do you understand that we proved that?
Mm-hmm.
That's it. We proved all formulas. Yes, definitely. We have formulas and for cotangent of 2 theta and for secant of 2 theta and for cosecant of 2 theta, but they're quite complicated, and this is what something really extra for advanced trigonometric study, and this is not a requirement. This is why it was absolutely normal to just use these formulas, because we all the time can convert, let's say, cotangent of 2 theta into 1 over tangent of 2 theta. And we have a formula for tangent of 2 theta. Let's say secant of 2 theta. Secant of 2 theta equals to 1 over cosine of 2 theta. Do you understand what I'm talking about? And same thing we can do with cosecants. I am on the page number 237. And here, first of all, please go over all solved examples in your textbook as well, because what I have in my notes, or if what you will have in your notes, excuse me, after my lecture, plus all these problems which are solved with all details, I think altogether it will be very helpful for you to comprehend the material. So I'm on page 237 and I'm going to grab one of problems, because again, I like to show right now few problems about trigonometric functions, sine, cosine, and tangent of double angle. First, let's say I'm looking at the spot which runs from 7 to 18. And I will show right now one of problems, but I will show you another one also from the same spot. This is why I will probably choose right now one of these right now, but you can also look at all these problems and choose your own, and you can ask me to solve it during our today's lecture. Are you okay with problem, let's say number 8?
Yes.
Yes.
Yeah.
Is it okay? Yes, okay. So page 237, problem number 8. I will not solve all this problem completely because it has 4 questions here, A, B, C, and D. I will be only solving A and B part because C and D is about half angle. So basically I will have a right to come back after the break. Probably I will show you C and D also, because first I need to introduce you with the formulas of half angles. Okay, so what do we have here in number 8? What is given? Cosine of theta equals 3/5. And our theta is between 0 and pi over 2. If our angle is between 0 and pi over 2, can I say that it belongs to the first quadrant?
Yes.
Yep.
Excellent. This what I wrote down. Cosine theta equals to 3/5. It is between 0 and pi over 2. In other words, it belongs to the first quadrant. And what should I find in part A? I am asked to find sine of 2 theta. Question in part A is about sine of 2 theta. Excellent. First, I'm going to write right after sine of 2 theta. It is equal to 2 sine theta times cosine theta. Is it what we got in formula number 1?
Yeah.
Yes.
I'm going to underline the part of that which already given, which I know is equal to 3/5, and I will place a question mark above that part, which I need to find. I am putting a wave below that part. Can you see what I did? So which means I cannot immediately write down what it is equal to because I'm missing sine theta value, right?
Yeah.
Yes?
Yes.
Yes.
But ladies and gentlemen, if I know that this theta belongs to the first quadrant, which means I know the location of the angle, and I know that cosine theta equals to 3/5, can I find the sine value of that angle?
Yes.
Yes, I can.
Mhm.
On the side, I will write that sine squared theta equals 1 minus cosine squared. Is it correct?
Yep.
Can we plug 3/5 and square it instead of cosine?
Yeah.
So it will be 1 minus, if you square 3/5, is it 9/25?
Yes.
Yes.
If you subtract 9/25 from 1, what do you get?
16/25.
Absolutely, yeah, 16/25. But I'm not interested in sine squared. I need to get first power of sine of theta. Can I take square root from both sides?
Mhm.
And now the location of that angle will help us a lot, because when we take that square root, we need to use or plus or minus for the certain angle. My question is, what kind of sign, plus or minus, should we choose here? Because don't forget, theta is from the first quadrant, so sine theta will be equal to what?
4/5, positive 4/5.
Absolutely accepted. This is what I wrote down. Sine theta equals to positive 4/5. That's it. I don't have any missing parts anymore. I will continue. You can see I wrote an equal sign after that, and I'm writing down 2 times 4/5 times 3/5. And now I simply can multiply these numbers to get the value of that sine of double angle. 2 times 4 is 8. 8 times 3 is 24. 5 times 5 is 25. Voila. This is your value, and or in other words, answer for part A. Can you see how easily we got that value?
Yes.
Excellent. Now, part B. And here we have a dilemma, because we have here cosine of 2 theta. And for cosine of 2 theta, we have three different formulas. Which one would you choose? Number 2, number 3, or number 4? And give me your reason for your choice. Guys, look at your notes. You have 3 formulas for cosine of 2 theta. And definitely, nobody can blame you for using, let's say, that formula or the other formula or the third formula. It is completely up to you. But which one will be the most proper for that type of problem, more justified to be used? Okay, do you need my help?
Yes.
Excellent. Let's look at all these formulas. And I have these formulas on that paper. One formula, which is number 2, look at your notes, is cosine squared theta minus sine squared theta. What I'm using here, and cosine and sine, right?
Yeah.
Yes.
In number 3, which is cosine to theta equal to 1 minus 2 sine squared, I'm using only sine value. And in number 4, I'm using only cosine value because it is equal to cosine of 2 theta equal to 2 cosine squared theta minus 1. Look at the given part in this problem. What was given?
Cosine.
Cosine. Definitely in the process, because we first found the sine of 2 theta value, we were forced to find sine theta. But we found that value. Maybe in the process, we made a mistake. No, we did not make a mistake, I guarantee. But what I'm saying, maybe. This why, if you are using formula number 2, which has sine in it, or using formula number 3, which only has sines, no cosines, if you made a mistake when you were looking for value of sine theta, your answer for part B also will be incorrect. To eliminate this possible problem, the best will be formula number 4, because in formula number 4, we have only cosines. And cosine value was given in this problem. This is for sure, is 3/5, no other question. Do you understand my point?
Yeah.
This why, again, it is up to you, because we now have a cosine value which was given, and we found sine value. You can use in formula number 2 or formula number 3 or formula number 4. Nobody can blame you for that, specifically if you found everything correctly. But if I were you, I would prefer to use that formula which has given information, not something what I found in the process. This why, do you let me, actually after my explanation, do you let me apply formula number 4?
Yeah.
Yes.
Thank you, you are very kind. I'm going to write it down, 2 cosine squared theta minus 1, which I did. This is formula, application of formula number 4. And I'm going to plug that given value, so it will be 2, parenthesis, 3/5 squared is 9 over 25. close parenthesis, minus 1. This is 3/5 squared in parentheses. And now I'm multiplying. 2 times 9 is 18 over 25 minus 1. What do you get if you have here, what? 18/25 minus 1. Please proceed to the answer. Is it going to be negative? Guys,
Yes.
7.
if you subtract 25 from 18, what do you get?
Negative 7 25th.
Okay. Negative 7/25. Please have that minus in front of that fraction.
Could you leap up a little bit?
You have difficulty seeing what I wrote down?
Nope, no.
Can you see now?
Yeah. Okay.
I will go an extra mile right now. And this is why I'm not going to mark this as a new number. I am going to write down that it is A plus B with the star part. Look what I wrote, A plus B with the star. I will go an extra mile and now I can find tangent of 2 theta. They did not ask me about that. I volunteered to do that because it will be quite interesting. And look what happens here. Do we have a separate formula for tangent of 2 theta?
Yes.
Was it formula number 5?
Yes.
Can we apply here?
Yes.
Yes, we can, but I probably will not. Why? Because if I expand right now this expression, again, is it legal? Oh, yeah. But for this application of that formula here, you need to know the value of tangent of theta. So I already know value of cosine theta, it was given. I already found value of sine of theta. In the process, I found that value. So basically to find tangent theta, I need to divide sine theta by cosine theta, simplify, and it will be that value for tangent theta. But why should I do that? Why should I go an extra mile to find additionally tangent theta? Can I say that tangent of 2 theta equals to sine of 2 theta over cosine of 2 theta, ladies and gentlemen? Is it true?
Yeah.
Yep.
Yes.
Do we have already value of sine of 2 theta?
Yes.
Yeah.
Do we have already the value of cosine of 2 theta?
Yes.
Definitely it will be better way to do what I just wrote down, to use this method, because in this case I don't need to find any other new missing value like tangent theta. I will just simply plug the value of sine of 2 theta, which is 24 over 25th. I will plug the value of cosine of 2 theta, negative 7/25th. And we'll proceed positive divided by negative is negative. So it will be negative 24 over 25 times 25 over 7. I will cancel both 25s and I am getting the answer for tangent of 2 theta very easily using cosine of 2 theta and sine of 2 theta. So please all the time analyze what you have, what you got the value for in the process of solving the problem, and look precisely at the given part. if you can use just given part to solve the problem, go for that, because it will be practically guaranteed that you are eliminating any possible mistake. Are you okay with everything what you see on the screen?
Yeah.
Yes.
Yes.
Okay. I don't know why so many students are quite passive during our lectures, and some people, which is very nice to hear, are quite active, because I definitely remember your voices and I know who is replying to my questions. They will definitely will be eligible for a higher class participation grades. And I really encourage all others to be as active as these people. This will be for your benefits. Do you let me right now stop declaring our short 5 minutes break?
Okay.
That's okay.
Okay, so what is the time right now? Just 1 second. Oh, 11:15. So I will continue at 11:20. Okay, so I
Okay.
do not say goodbye.
Okay.
Okay, guys, are you back?
Yes.
Yes.
I discovered very interesting fact, and definitely it is not about you guys who came back, but I saw some students who actually at the beginning were here, and immediately after I started my lecture, they disappeared. Definitely, I hope that they at some moment can watch that video, and I'm marking them as absent because they disappeared. I can see all names of participating people right here on the side. And I will not have blind eye anymore on this kind of behavior. Now I will continue. I am going to prove right now formulas for half angles. And first thing what I like to ask you is to look at formula number 6. Formula number 6, which is on page number 232. This is actually a formula which already represents half angle formula. Why? Because what do you see here? In this formula, on the left side, if you can see, you see sine square of theta. On the right side, you can see cosine of 2 theta. This is the formula which you have in number 6. Sine square theta equals 1 minus cosine of 2 theta over 2. We have here theta, and we have here 2 theta. Can we say that theta is a half of 2 theta?
Yeah.
And I provided actually the proof for that formula, which is you can see right there during the break time, I wrote it down. To prove this formula, I used formula number 3, which we proved today, because in this formula, I had sine squared theta on the right side and cosine of 2 theta. Basically, I grabbed that formula and solved this for sine squared theta. Absolutely, in the same manner, and I'm not going to prove right now other 2 formulas because they are very similar to that. If you this time will be using formula number 4, formula from formula, yeah, I can't even write from formula number 4, you can get what? You can get formula number 7 if you are going to solve formula number 4 for cosine squared theta. You will get cosine squared theta equals fractional line 1 plus cosine of 2 theta on the top and 2 is on the bottom. You can easily get this formula, and this is formula number 7. Formula number 7. The proof is very similar to what I did for formula number 6. And finally, on this page number 232, you have formula number 8 for tangent of half angle. And what can I do? Can I treat again tangent? First, let me write it down. 1 minus cosine of 2 theta over 1 plus cosine of 2 theta. This is the formula number 8. Tangent square theta. Okay, I will quickly prove it right now. Tangent square theta, is it sine square theta over cosine square theta?
Yes.
Please write it down. Now, instead of sine squared theta, can I write what I have in formula number 6? 1 minus cosine of 2 theta over 2. And instead of cosine square, I will write what I had in formula number 7, 1 plus cosine of 2 theta over 2. Right? And now I will divide fraction by fraction. How do we divide fraction by fraction? We keep the first fraction unchanged, and we convert this into multiplication by the reciprocal of the second one. We will cancel what we can cancel. We cancel 2's, and we are getting 1 minus cosine of 2 theta over 1 plus cosine of 2 theta. Voila, this what we have. We proved that formula. Is it okay?
Yeah.
So now, this section has tons of formulas. Now, what about box which is named like formula number 9? In the box number 9, we have 3 different formulas, but they are not brand new formulas. These are versions of formulas 6, 7, and 8, in which they just replace theta by alpha over 2. And instead of theta, they used alpha. Why? Because traditionally, they like to show formulas in their forms, how they look for trigonometric functions of half angles. Yes, theta is a half of 2 theta, but they just wrote same formulas as we had in number 6, 7, and 8 and 9. Oh, excuse me, 6, 7, and 8 in terms of alpha. And this why for formula number 6, in terms of alpha, we have sine square alpha over 2 equals 1 minus cosine alpha, because again, they got rid of theta and 2 theta. And instead of theta, they used alpha over 2, which is half of alpha. And instead of 2 theta, they are using alpha. Can we say that alpha over 2 is a half of alpha?
Yeah.
Same thing as we said that theta was half of 2 theta. This is same formula. Absolutely, this is the same formula. So in the box 9 formula, first one for sine square alpha over 2, it is same formula like number 6, only instead of theta, they are using alpha and alpha over 2. In the same way, if you look at formula in your box number 7 and replace theta by alpha over 2 and replace 2 theta by alpha, you are getting absolutely same thing with alphas only. Same thing as you had in formula number 7, plus cosine alpha over 2. This is the formula. And using the same method, if you have in formula number 8, theta equal to alpha over 2 and 2 theta equal to alpha, then you will get the last formula in that box number 9. Tangent square alpha over 2 equals 1 minus cosine of alpha over 1 plus cosine of alpha. And this all was in box number 2. Below each one, I will write for references the corresponding formulas with thetas. So this is for formula number 7, and this is for formula number 8. So this what I did. I showed the connection that there are same formulas, only written in terms of alpha and alpha over 2. And below, for references, I provided the corresponding formulas which carried thetas and 2 theta. But now, from these formulas in box number 9, we can easily get 3 new formulas, 10a, 10b, and 10c, which you have on the same page. If you look at first formula in box under number 9, you can see it has sine squared of alpha over 2. If you take square root from both sides, you are getting sine squared alpha over 2. We don't need. You are taking square root. And you are taking square root from the other side. I am showing this in the process. I will show this for this first formula. Today is a little bit dark, no sun shining in San Francisco. This is why probably you have quite dark screen. Do you?
Yeah.
So, but because we took square root, we need to consider plus or minus sign because we do not know the location for that alpha. This is why in the formula we are using plus or minus. Later, when we solve problems, we will look at the location for half angle and we will choose or plus or minus, but not here. Here, you need to write both signs. Again, we have, and this is your formula number 10a. This is your 10a formula. So I showed this in the process. But I would like to just copy formulas 10b and 10c, not showing the proof because it is done, it should be done absolutely in the same way. So again, if we have second formula from box number 9 and take square root from both sides, we will get cosine alpha over 2 equals plus or minus square root 1 plus cosine alpha over 2. And this is in your textbook formula number 10b. I even separated them. 10b. And same thing with the last formula, tangent square alpha over 2. We have in formula, in the last formula in that box, take square root from both sides and you will be getting formula 10c, tangent alpha over 2 equals plus or minus square root 1 minus cosine alpha over 1 plus cosine alpha. And we are done with that 10a, 10b, and 10c. I know you are probably already tired of all these formulas, but yeah, we have too many. And finally, you have only one formula, one box actually, number 11, which I'm going to write right now. And after that, I will finish part C and D from the problem which I just showed today, because again, this section has too many formulas. So what do we have in problem number 11? I am not going to provide right now the solution. Yes, it is absolutely can be done. If we work, let's say, with formula number 10c and simply manipulate with that expression under the square root, if I have at the end of semester extra time to do that, I will prove that formula. But trust me, these formulas are very useful. So in many cases, and I'm going to write them down, and please copy, or you can copy this from the textbook. It is on page 236 and the box number 11. There are two actually formulas because here we have two expressions. Again, we have here many formulas, definitely too many that we have here. And double angles and half angles, basically two sections united in one. So this is the last formula here from this section. And we right now are equipped by all formulas. Okay. With your permission, can I go back to that problem which we solved part A and B for?
Yeah.
Okay, so now part C. In part C, I was asked to find sine of theta over 2. Sine of theta over 2. What am I going to do? Definitely, I am looking at the proper formula, and the most proper formula is number 10a. Formula 10a states sine alpha over 2 equals plus or minus square root 1 minus cosine of alpha over 2. I'm just reminding you that formula which I am going to use. So only in my problem, instead of alpha, I have theta. Not big deal. But first, I would like to find a location for theta. What am I going to use? In the given part, you had theta between 0 and pi over 2. Do you remember that? Yes?
Yep.
But in your problem, you have sine of theta over 2. What should you do? Divide all three sides of this inequality by 2, because you need to get a location for theta over 2. 2 is a positive number. If you divide inequalities by positive numbers, you should not change the signs of inequality. You keep what you had. 0 over 2 is 0. Theta over 2 is theta over 2. And pi over 2 divided by 2 is pi over 4. In other words, 90 degrees divided by 2 is pi over 4. This is what you got. This is a location for theta over 2. If your theta over 2 is between 0 and pi over 4, it belongs to which quadrant? Is it still the first quadrant?
Yes.
Yep.
This is enough. I know that theta over 2 is from the first quadrant. This means in the first quadrant, sine is positive. This is why, look what I'm going to write. Sine of theta over 2 will be equal to positive sine square root 1 minus cosine of theta over 2. I adjusted formula because I already know that theta over 2 belongs to the first quadrant. In the first quadrant, sine is positive. I'm going to plug right now that value. Cosine was 3/5, 1 minus 3/5 over 2. And I'm going to solve this right now. 1 minus 3/5, it will be 2/5 divided by 2, which is square root 2/5 times 1/2. And I will cancel 2 with 2. And I'm getting square root of 1/5, but I will not leave it as an answer. Square root of 1/5 is square root of 1, which is 1, over square root of 5th. And I'm getting square root in denominator. I need to get rid of that. How? Easily. It is 1 over square root of 5 times square root of 5 over square root of 5. I multiplied the numerator and denominator by square root of 5 to get rid of that root which I had previously in denominator. This will give me square root of 5 over 5, and this is my answer for part C. This is my answer for part C. I am done. Part D will be shorter because I already know that theta over 2 is from the first quadrant. In the first quadrant, cosine is also positive. So part D, this is quite a big problem. Definitely we had A, B, C, and D questions, and we need to find quite many answers for many questions here before we solve. But I will be using formula number 10b because I am asked here to find the cosine of theta over 2. So from 10b formula, I had cosine of theta over 2 equals plus or minus square root of 1 plus cosine alpha over 2. Instead of alpha, I have theta, and I know that my theta over 2 is from the first quadrant. This is why I'm going to adjust that formula, and I'm getting cosine of theta over 2 also equals to positive sign 1 plus cosine theta over 2. I'm going to show this to you right now. This is what I wrote down. First, I again copied formula 10b and adjusted that formula. And now I'm going to plug, instead of cosine theta, its value, which is 3/5. Everything divided by 2. 1 plus 3/5, it is 8/5 over 2, which is square root of 8/5 times 1/2. And I can cancel 8 with 2 by 2. So 4. So it will be 4 times 1, 4/5. I got 4/5, but square root of 4 is 2. And I'm getting 2 over square root of 5. And again, I would not keep that square root of 5 in denominator. This is why I will multiply top and the bottom by square root of 5 and proceed to the last step, which will be our answer in it. So it will be 2 square root of 5 over 5, and this is your answer for part D. We completely solved all these A and B and C and D parts. And in between, I introduced you with thousands of formulas in this section. Did you understand the process?
Yes.
Yeah.
Definitely. I really recommend everyone to watch that video again for better understanding, because you were showered here by tons of formulas. Now I'd like to say about coming quiz. I will offer this quiz to you as I offered you your test. I will offer this using my math lab. So, and it will be offered to you the next time at the end of our lecture. So I will release you about 15 minutes before the end of the lecture. And after I tell you to start that quiz, you need to go directly to my math lab, find that quiz, and solve all problems offered in that quiz in exactly the same way as you worked with your test, which you also took through your My Math Lab. Do you have questions about that?
No questions.
No.
I would really like to ask you to very seriously look at all these formulas, because I definitely will solve more problems about from this section, because again, it had too many formulas, because here we had actually 2 sections combined in one. But please review all values and all formulas, because I teach not only your class, I teach pre-calculus class, and I immediately see in pre-calculus class what they did in trigonometry course, not probably learning many. I'm not talking about all students, but quite big part of the class are struggling with trigonometry. Please, I do not want to see the same struggle with you guys for the next level. This is why I try and not to only show that formulas. I'm proving, I'm all the time recommending you, look, we can use that formula and that formula and that formula, but this will be more beneficial if we use that, but not that. So I'm doing this for your benefits. Try to think about all these formulas very seriously, and specifically values of trigonometric functions. If you do not have additional questions, can I end today's lecture?
Yes.
Yeah.
Yeah.
Thank you, dear ladies and gentlemen. Thank you for being here. And I hope that we will successfully overcome altogether this difficult time in our country. Please stay healthy and very safe, and be extra careful when you go for shopping or visit other public places. I wish you a good day today, and warm goodbye to everyone. Okay?
Thank you.
Bye.
Bye, guys. Bye.
Bye.
Thank you.